Okay, so now we're going to go ahead and take a look here at example number 2 and example number 3. In example number 2, we'll see that a random sample of times in minutes of how long students take to answer a Chapter 9 stats question is taken. The distribution of times, let's say, is normally distributed. And these are all the different times that it takes. So, 3 minutes, 4 minutes, 5 minutes, things like that. I want to construct and interpret a 90% confidence interval for the overall population mean. Okay, so I kind of want the average. All right, so I can tell then immediately I'm in the same exact spot in the formula sheet I was a moment ago. Let's go ahead and write down all the associated information that I have. First thing I could ask is, how many different people were surveyed here? Well, I guess I'd have to go count them up. Let's see, I got 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 people. Now, the other stuff that I would normally have written down, like in the last question, would have been an X bar and an S. But in this case, I'll actually find that I don't need to record those values because I was given raw data. So here I'm going to say that I'm going to enter data into L1, or you could really just say into any list. So I'm going to go to the calculator and do that in just a moment. But before I do that, I'm going to just run the checks just to make sure here that everything is good to go. Do I have a big enough sample size? Well, no, I only have 9. But I am told the distribution, get rid of the calculator here, the distribution of times is normally distributed. So that checks off I feel confident that I'm able to proceed with the confidence interval. So I'll put up a little space here to record my interval and a space to provide my interpretation. Okay, now let's go to the calculator and we'll actually go and enter all of this data into a list and then use that t interval to figure out what the interval looks like. Okay, so I'm going to go to stat. I'm going to go to edit right away because remember I want to put this stuff into lists. And if you already have stuff in your lists, no big deal. I would just delete it out of there or clear it out of there. Don't hit the delete key. And then I can start entering these. So of course I got to be careful. I want to make sure I type in everything correctly because if I don't, then obviously I'll get the wrong answer at the end. So I have my 9 values typed in. Then what I can do is I can go to stat, go back to tests, go down to that t interval, and instead of using stats, I can just use data. This will make the calculator do all the hard work of finding the average, finding the standard deviation, because otherwise I have to run a 1var stats and then write those values down, and then I got to plug them back in, and this just becomes an easier approach. I'll just say, calculator, my data is in list number 1. The confidence level that I want is a 90% confidence level, and calculate. It says 3.9591 to 4.6409. Okay, so I should be able to then write my interpretation. Notice though, before I write that, you'll see that the calculator does actually tell me my X bar, which is what should be at the center of my interval, smack dab in between, and it gives me my standard deviation and reconfirms my sample size of 9. Okay, so for my interpretation, I can say that we are 90% confident that the average time to complete a Chapter 9 stats question for all students is between 3.9591 and 4.6409 minutes. Very clearly here the units are minutes, and I'm always going to ask that you write down those units. Okay? Okay, well hopefully that doesn't feel too different than what we did back in example number 1. As long as I record all my data, do my checks, write that interval and the interpretation, I'm good to go. All right, so I want to go then and take a look here at example number 3, because we're going to see something kind of interesting happen here on this question. Let's see what number 3 says. In a recent season, the yards per carry for running backs are going to be studied. So running back is a position in football. They're the person that runs the ball. They get it handed to them and they try to run. Usually it's pretty hard in football. You don't actually get to run very far because most of the time you get tackled very, very quickly. So the yards per carry of 20 randomly selected running backs are listed below. So this is what they got. This was kind of what they were able to earn during the season. Typically, the first person here was able to run about 5.6 yards. And what we're going to be interested in doing is constructing and interpreting a 95% interval for the average yards per carry. Again, this question is giving perfectly away that I'm dealing with an average. Okay, again, I might go ahead and start by listing out what's my N. Well, in this case, we were told that it's 20, right? I have 20 running backs. And I don't want to go ahead and enter all this data and then compute the average and standard deviation by hand. So I'm going to enter all of this data into a list. I'm going to use L1 again, so I'm going to get rid of that old data in just a moment. But of course, before I do that, I might be interested in running my checks. Okay, so really quickly, do I have a big enough sample size? No, yeah, I don't have a big enough sample size because I don't have more than 30 or exactly 30. Am I told anywhere that the population is normally distributed? No. So this is kind of a big dilemma right now. Does it look like either of my two checks are going to be met? At the moment, it doesn't. And what that would mean is that I wouldn't be able to continue with the problem. However, there is something I can do to check that second check. I'll state here that we can check to see if the data comes from a normal population by making a normal probability plot. That's something that we did back in section 5.3. And gosh, it's been a long time since we've done one of these, but we'll see from time to time, this becomes a really important thing to be able to do. So I'm going to go ahead and actually try to do this here. I'll recap for you exactly how I'm supposed to reconstruct one of those. So the first things first, I'm going to go ahead here and enter all of my data into a nice list so I can work with it. And then I'll make this picture. I'll see if I can check. I'm almost out of space here as well on the page, so I'm going to have to really try to squeeze in the rest of what I got. Okay, so let's see. First, I got to enter in all my values, making sure that I don't make any typos. Okay, once all my data values are in, remember that I can go ahead and I can actually create the normal probability plot in the following way. I'll click on the second button, then on the y equals where it says stat plot above in blue, and I'm going to go to this first option, which might be on. If you have other options on, like I do here, you can go in and turn them off just so you don't have to see them. Now I'm going to just go and look at this first option. And again, the normal probability plot is this very last picture over on the side. It's this one. That's the one I want to select. It's going to ask me where my data is located, and I'm going to tell it list number 1. The rest of the information never needs to be changed. Then I can hit zoom and 9. And here's a picture that I create. Now what I'm going to do is I'm going to draw this picture really quickly on the page, just as a confirmation that I actually did this portion of the question. I don't want to provide a perfect sketch, but maybe just a rough sketch, right? Something, I don't know, goes like this, then it goes up, then over, and then there was one over there, right? This is like a rough picture of what I got. And the question is, does this look roughly linear? And we'll say Since this looks roughly linear, we know we can go to check number 2 and say that we can check that off, which seems reasonable that the data comes from a normal population. So we'll say the data likely comes from a normal population. So our check is met. Well, now I can go ahead and construct the interval in the same way I did before, and then I can provide an interpretation. I'll actually be able to squeeze the interpretation in right here. So let's go ahead and construct the interval now. Okay, let's see. I'm going to go ahead and go back to stat, tests. I'm going to go to my t-test. I have all my information sitting in here. I'm told, though, that I want to construct a 95% confidence interval, so I'm going to have to change that to 95 and run. So I get 3.7675 to 4.8325. So when I write my interpretation, I can kind of start by just saying, we are 95% confident the average yards per carry for all running backs is between 3.7675 and 4.8325 yards. Done. Notice that this question was able to be done because we were able to complete the check, which was only able to be done because we had raw data. If we didn't have any raw data here, we would have totally been stuck, and it would have been completely appropriate to say the checks aren't met and I can't continue. Okay. Again, I would encourage you to go ahead and try to practice this with the worksheets that we have before you even take a look at the next video. In the next video, though, we'll start to talk about how can I do minimum sample sizes, but to estimate mystery averages.